So we'll skip that and see if we regret it later. If any of you were on the stream earlier, you probably heard me say maybe we'll come to regret that later. Awesome. Yeah, sounds broken, so I'm surprised you can even still hear my microphone. Hey everybody, welcome back. My name's Mike. This video is a recap of a live stream that I did recently where I showed how to implement wavetable synthesis and wave shaping from scratch using Ruby code. Now, if you just want to hear what it sounds like, here are some demos that I made after the stream to show off the wavetable synthesis. Wavetable synthesis, or in the case of what we're going to be implementing, I believe it's called multi-wavetable synthesis, is a way of creating sound waves. Then you might be asking, what is a wave? A wave is any kind of amplitude varying over time. Episode 1 and 4 of my video series from a couple years ago talk about these things. A wave can have different shapes, and that changes the way it sounds to our ears. We have sine waves. These are the simplest, smoothest sounding wave. Square waves, ramp waves, or sawtooth waves. They're called this because they kind of look like a ramp. We can add two sine waves together to get another wave that's like a sine wave, but a little more interesting. And then waves can get more complicated from there. What wavetable synthesis does for us is it lets us stack up a bunch of different waves together. And then by switching between these different waves very quickly, we can generate interesting sounds. So a little bit of the mathematical background that's going to help us as we implement this wavetable code. A wave is represented by a computer as a list of numbers. Each number corresponds to the amplitude of that wave at a given point in time. With a wave table, we list out multiple waves, and then our wavetable synthesizer will let us say, I want to play wave 0, and then I want to switch to wave 1 and wave 3. If you're familiar with matrix math, that probably sounds a lot like a matrix to you, and that's kind of how we'll be representing our wavetable in the computer as a matrix. While I was doing my research, these are some of the questions that I came up with. These are the questions that by answering them, we will have created a wavetable synthesizer. So basically what we're trying to do here, we're trying to create a magical wavetable machine. We don't know exactly what this machine does yet, which is why it's called magical. But we know the inputs and the outputs of the machine, and by studying these inputs and outputs, we can learn what the machine should do on the inside. So in the case of our wavetable machine, our two inputs are phase and the wave number. The phase is that horizontal component from the matrix that I showed earlier. The wave number is the vertical component of the matrix. Phase is actually derived from two other inputs, time and frequency. Frequency is the note that we play, and of course, we know what time is. And then when we tell our magical wavetable machine, I want this phase and this wave number, it gives us a sample value, and we send that sample value out to our sound card to make sound. From a mathematical perspective, what our machine is a function that takes two parameters, phase and wave number, and gives us a return value from -1 to 1. And then from a code perspective, similarly, we need a function that will take phase and wave number as input and return a floating point number as our output. For those of you who are familiar with graphics, in theory, someone could use a GPU to implement a wavetable synthesizer. First of all, this is my sound library, MB Sound. We're going to start out by playing a simple sine wave. And that's our basic sine wave. We have triangle waves. We have square waves. And of course we have our ramp wave. I'll just add a filter to our ramp wave that changes over time. So hopefully you can see that by taking these simple building blocks and combining them together, we can make more and more sophisticated and interesting sounds. With wavetable synthesis, we can take some of these existing waves and we can take sounds that we record, combine them together into a wavetable, and make new interesting sounds. So let's dive into the code. We have a completely empty Ruby class. I always like to document what I'm doing, so we're going to start out by documenting and then go through those functions that are in our list. Okay, you should be able to see the notes on screen for what we need to do. And I'm noting the data structure we'll be using for internal storage. You'll note I'm not using AI. By typing out the code, I find that I have a better mental model of it, and then it's easier to make changes over time. For those of you who are familiar with sound, as I researched this, I thought the easiest way to implement it with my existing system would be to basically make it as a wave shaper and then play a ramp wave into the wave shaper, and that will give the exact same result as making a wavetable oscillator. But what happens if we try 1.5 and 3.2? It doesn't blend them together like we would want it to. It's just taking that number from the beginning, the 1 and the 3, rather than blending between values. We'll need to retrieve two values and blend between them ourselves. We want to know how many columns there are, so let's shape 1 for the second element of the shape array. The percent equals will wrap it around so that if we go beyond the end of our array, we start back at the beginning. Now we have the two columns that we're pulling from. We need to know how much to blend them together. So it's time for some debugging. Ratio is 15.7. That's the problem. So we didn't wrap the ratio around. It's worth noting that Ruby's modulus operator works a little bit different from the fmod function in C, if any of you are familiar with that. Now we have something more reasonable looking. Mark that completed in the notes. Now we need the column lookup. Let's call them inner and outer lookup for now. The modulus probably isn't required here because we already did a modulus up here. So we'll skip that and see if we regret it later. Now, since these two functions are done, I'm going to write the documentation for them. It's always very good practice to document as we go. Just to recap where we are, we have written a function that will blend between two columns in a row of the wavetable. That gives us our sound amplitude from one wave. And then our other function blends between two rows in the wavetable so we can blend two waves together. The last thing we need is a function that will take these two existing functions and call them repeatedly for each sample in a loop, and that will give us our sound. One thing we didn't test actually is what happens when we change the number. if the wave number goes past the end, we get this index error. If any of you were on the stream earlier, you probably heard me say maybe we'll come to regret that later. We needed to ensure that our row numbers stay within bounds. So now if I load the code again, and then come up to the line where we have this 1.5, it actually works. It doesn't crash this time. So we need to take this function and bring it into the code structure of the rest of my code so we can make some music with it. And finally, our phase is going to be self. We need a wavetable first. That's created our wavetable and given us the code that we need to load the wavetable. Third time's the charm, or however many times this is. Nice! That's our first wavetable synthesis. Now let's try the second wave in the table. So that was wave 0, let's try wave 1. And we're getting a different sound there. Let's try wave 2. It's working! Here's where wavetable synthesis gets interesting. We don't have to just pick one wave. Fingers crossed that this works. This is the line of code that we'll be running. And it's interesting, there's some silence at the end. I'm not sure what's up with that. So let's change this instead to vary from 0 to 4. Is our last wave entry flat? It is. So yeah, the last entry is actually silent. Interesting. And now I know that's not the most impressive sound in the world, but that is basic wavetable synthesis where we can blend across our wavetable. But we can also make things more interesting. Let's try this at 0 to 1. Okay, so we were actually kind of doubling the frequency of our wave by going from -1 to 1. We can go 0 to 3, which will triple our frequency. And then we can add an LFO to that. So we'll go 0 to 1, and then we'll multiply this by an LFO. Reload our code. now we're getting a little more interesting with the wavetable synthesis. So we're varying wave numbers, and we're also varying how far we look through the wave. Let's drop our frequency an octave. And instead of a ramp wave, let's do sine wave. And this is an awful lot like FM synthesis, so this is pretty fun. Awesome. I don't know about any of you, but I'm pretty happy with that as a first result. All that's left to do is wire this up with MIDI. Yeah, so I'm not getting any MIDI. That probably means the MIDI system of the computer has stopped working. To restart that, I have to stop the stream. Okay, MIDI is working now. So let's see if we can connect MIDI to our wavetable synthesizer. Now that MIDI's working, last thing to do is to make it so that we can control some of the other parameters from the keyboard using the joystick. Okay, so now I should be able to choose the wave with the joystick on the keyboard. Okay, why did the sound stop? Come on. This system's so flaky. But it's control number 2. This unreliability gets frustrating. Yeah, the sound broke again. Okay, that's very frustrating. We were actually able to produce wavetable synthesis. You can actually see the visualization of it on screen now. And connected it to the keyboard so we could play the wavetable with MIDI. Like my last stream, I'm going to end it on a crash. Thank you all for watching. It's been a lot of fun actually implementing wavetable synthesis. I've been wanting to do this for a really long time. If you want to learn more about wavetable synthesis, I have put links in the description. That's it for tonight. I've got to do some debugging on my system, and I won't make any of you watch that with me. And I was going to play some outro music, but yeah, sound's broken, so I'm surprised you can even still hear my microphone, but for real this time. See y'all. Yeah, okay. Touchscreen with pen doesn't work well. Gotta set the pen down. Come on, OneNote. Since I'm one of the 2 people watching, I don't think anyone's gonna have any questions right now. I don't know if those numbers are reasonable, but they seem like it, so we're gonna move forward. I can see the number like going up and down. It's the worst possible time to be joining, so unfortunately this is the end.